Blaster Datapacks. This is something that we've been working on for a while, and it has just now gotten to the state where we're ready to kind of show everybody what they need to be doing to add their own. There are still changes that we plan on making in the future with regards to how attachments work, because obviously we've got the Blaster Workbench now, and you can add visual attachments, but they don't do anything yet. But that's something that we'll be discussing and revising in the future. But as it currently stands right now, you can at least add your own blasters as a data pack for people in your world and on servers, and you can add attachments for those blasters. And that is what today's discussion is about in its entirety. So what are data packs? The easiest way to introduce them is to compare them to resource packs, which I assume many people are familiar with. Resource packs evolved from texture packs, which have been in the game for years and years, well over a decade at this point. It allows you to add textures and models and sounds and anything that's really relevant to the client. So language files fall under that. These are all things that apply globally to the client. So you enable one resource pack or maybe a couple resource packs, and it can reskin your client, the blocks in your world. It makes sound different, stuff like that. It's basically a texture pack for the whole game. It's just for you, though. Nobody else sees the texture pack that you have applied. The world itself and the server, if you're running a server, are totally unaware that there is even a resource pack being used. It's something that truly only you can see. And so it's not useful for adding functionality itself, but it's useful for making functionality look good, and that's something we'll get into. Data packs, kind of conversely, are pretty new. They were added in 1.13, and they add functionality. They don't add assets specifically. So they would add things like dimensions and recipes and block tags and stuff like that. Not block models or block states, which are all in resource packs, but truly the core functionality. And they're not global to your client. Each world and each server that you run can have data packs associated individually with it. So the server will load all of the information in the data pack, and when new players join the world or the server, they will sync that information to the client. So the client doesn't need to have the resource pack, or rather the data pack. The client doesn't need to have the data pack. They'll just have that information given to them by whatever server they connect to. It's seamless. Now, both are required for adding new blasters. And we'll get into why, but there's a visual component and there is a functional component to blasters, so we'll be talking about both. So what do blasters need? Like, why do we need both a data pack and a resource pack? Well, on the resource pack side, you're going to need a model for the blaster. You're going to need a texture for that model. You're going to need a language file so that players can have the name of the blaster and the name of the attachments translated into whatever language they're playing the game in, or usually the fallback is English. And optionally a sound that the blaster makes when it fires. In the data pack, so the functional side of things, it's just the item definition. So the statistics about the blaster, the information about what sound it makes, what color the bolt is that it shoots, how much recoil it has, all of that is in the data pack. So probably the first thing that you're going to do if you want to add a blaster is create your model. Or maybe you've found a model that somebody else has made, or you've commissioned a model from somebody, but either way you're going to start with the model. If you choose to make it yourself, it really is irrelevant what software you choose to make it with. We use Blender because we like Blender. Where most of the team is familiar with it. Some of us have moved from Blender to Maya, or rather from Maya to Blender. And so the rest of this will be Blender specific. Or rather, most of the steps about working with your model are going to be Blender specific. But you can use anything that exports to either OBJ or STL, or anything that Blender would be happy to import. And the reason being is because you do need to use Blender to actually work with the models, as we're going to talk about in a minute. The first step for actually creating your model, it can happen wherever you want. So here's a model of this is actually a model that Cinda made. Just a rough blocking out of a Westar carbine in Blender, which is the bottom picture, and in Blockbench, which is the top picture. So either one of these options is totally fine. And just as long as you can get it into Blender, that's fine. So this is kind of nitpicky. Some of the things that you might want to consider when you're making your model, and this is stuff that you can review, on your own time. I'm not going to really hammer it home here. But in Blender, each pixel should be 0.1 meters, so 10 centimeters. And the reason for that, and despite that's not what the game uses. The game would use 1/16 of a meter, but 0.1 meters is just a nice round number. So we chose that. And all other blasters are based off of this scaling system. So if you want your blasters to be the right size when they're in game, you should probably make all of your pixels 0.1 meters. And if you want the blaster to roughly be the right size as the blasters that are currently in game, the trigger of the blaster itself should probably be around 3 pixels tall. And the reason for that is that between guns, people's hand sizes generally don't change. And so guns are going to use the same kind of grip and trigger area size, regardless of the power or the magnitude of the gun itself. So that's a good thing to kind of compare between two different models. And so some more nitpicky stuff in terms of coordinate systems. Up is Z, forward is Y, right is X. That's not something you really need to worry about. We're going to gloss over stuff like that. Rotation and scales is more Blender specific stuff. If you're importing, the big idea is that if you're importing from Blockbench, you need to rotate your model 180 degrees around the Z axis, which is up. So rotate it, make it face backwards essentially. And then you will be in the coordinate system that is ready to be put in game. So when you go to import your model, and this is only relevant if you didn't make your model in Blender, so you export it from your editor and import it back into Blender. Blender is a little bit peculiar. It wants you to select the format before you open it. So if you know what format you exported it in, go ahead and select it from the import menu. If you don't, it's probably OBJ. So that's a good first thing to try. You'll notice that when you import your model into Blender, that it's going to have an origin. And the origin is going to be centered at the middle of the world, or like the world space. And that's that little orange dot that's at the intersection between the X and the Y axes. Now, that isn't particularly conducive to having it in-game, because that means that all of the coordinates for the item itself are going to be relative to something that's not even attached to the blaster. So we want to move that origin dot up to where the trigger is, which is where all blasters are centered on in the mod, so that they're consistently held at the end of the hand, or at the end of the arm where a hand would be. And then you can go ahead and move that origin, to the middle, or to the origin of the object, to the origin of the world, so it's centered. Not strictly required, but is generally recommended. And these are all Blender specific things, and we're not going to go into how you actually move all this around, because you might not need to use Blender for this. It's also imperative that when it's in Blender, or in your editor, that the attachments for your gun are separated. So here, just kind of arbitrarily, I've split this model into 4 attachments just as a visual aid. So we've got the base gun there in the middle. We've got the stock in the back. We've got the scope on top, and we've got the underbarrel, obviously under the barrel. So you obviously don't need to split them apart like this. This is just a visual aid. But the key idea is that each attachment should be separate as a separate model, and each attachment should have a unique name, which you can see over there on the right in the Blender little scene browser. And like I said, separating them is strictly a visual aid. If you have multiple attachments that kind of occupy the same part on the blaster model, you're going to want to have them occupy the same place on the blaster model in the editor. And this seems confusing because they're going to overlap in the editor, but when they get rendered in-game, only one attachment, or the attachments that are selected by the player, will actually render. So in the editor, they should appear as overlapping, and that's normal. Shown here is the EE3. The EE3 has two barrels, a veined barrel and a smooth barrel, and has a tall scope and a short scope. And this is the difference between the Empire Strikes Back appearance of it and the Return of the Jedi appearance of it. And so for the player, they get to choose between either the veined or the smooth barrel, or the tall and the short scope, and they can mix and match if they so choose. But the key idea is that when the model is exported, that they all occupy the space that they should occupy when the model is rendered. You may find it useful to hide certain elements when you're not working with them, so it makes them easier to edit, so you're not looking at overlapping models constantly. It gets frustrating. But only visible attachments and models will be exported. So when you're done editing it, just make sure that all of the attachments are visible, and you'll be good to go. Shown on the right is the tall scope and the veined barrel hidden, which would be the model encircled in yellow. And so, as a brief aside, we're going to talk about sockets. And that's sort of a weird thing to get into, but like, what are sockets? Sockets are this invisible part of the model that doesn't have any actual mesh or texture associated with it. All it's doing is defining a location and a transformation, like a rotation, of specific features. And we can give this point and space and this orientation of that point a name, and that named point and transformation is a socket. So for example, a socket would be the position and the rotation of your offhand. As it gets rendered, your hand would connect to the bottom of the model, and where the muzzle flash renders. So here is your offhand rendering. The position and the rotation of that hand is defined by a socket, as we'll see later. And the muzzle blast here, or the muzzle flash, excuse me, shown here is also defined by a socket. So in Blender, blasters recognize empty arrows, or arrow empties if you prefer, as sockets. So shown on the right is an arrow empty. It is literally just a point in space that has some local coordinate system to it, so some local transformation. And as we noted in the things to consider, Y is forward, Z is up, and X is to the right. So we're kind of looking at this empty kind of from its front right top. So if you've got your model in Blender, the first socket that you're going to want to add is the main hand. The main hand socket should be exactly where the end of your hand in Minecraft should sit on the blaster, your main hand. So that would mean that your fingers are on the area where the trigger would be. And so we can see that here because the empty is right where the world origin is. So that means that the grip and the stock will render up the arm, and the barrel will render forward off the arm. And we call this socket main hand, all lowercase with an underscore. The next socket, and one that you may prefer to add a rotation to, is the offhand socket. The offhand, as we showed with the image earlier, defines where the second hand, if your blaster is big enough to have one, would render when the item is rendered. And that is with the offhand with an underscore socket. And this socket is entirely optional. If your blaster is not large enough to have an offhand or to require an offhand, you do not need to define it. But for this example, we are defining one. And a little more specifically, or a socket that has a little more featureness to it, is the muzzle flash socket. And in this particular example, there are no barrel attachments, and there is only one barrel length. So we defined one muzzle flash socket that sits at the very end of the barrel. That is where the muzzle flash will render when a shot is fired. And as noted here, the Westar doesn't have any barrel attachments, so only one muzzle flash socket is required. However, if we look at the barrels of the EE3, the one on the left is the smooth barrel, and the one on the right is the veined barrel. You'll see that they're different lengths. So in the left model, we have just the smooth barrel. So we define a socket that is at the end of the smooth barrel, and we define a socket for the right one that is at the end of the veined barrel. And these would not be to the left or right of each other on the actual model. And I believe I show that in a later slide. But the way that you would define it is you would have a muzzle flash socket with a period and then the name of the attachment that it refers to. So in game, if you have the smooth barrel attachment applied, the game will look for a socket called muzzle flash dot smooth barrel. If you have a veined barrel attachment applied, it'll look for muzzle flash dot vein barrel. And that should be pretty straightforward. Texturing is quite a bit of contention in Blender. It's not very friendly. I recommend, if texturing is not something, or UV mapping is not something that you are familiar with or not something that you've done in the past, I recommend that you import your model from an editor like Blockbench, which will allow you to export an OBJ or some other format that will have a texture map generated already for you. And the texture map for the Westar is shown here on the left. This is an example texture map, or a texture template that was exported for this gun by Blockbench. And so it already has all of the positions of the textures defined, and it has some example colors added for each face. This is the texture that Sind came up for this example. It is just drawn directly on top of the texture template. That's something that's pretty straightforward and applies to pretty much every Blockbench model anyway. When you go to export your model, you're going to export it in a very specific format. This format is called P3DI, and it is an intermediary format for the P3D models that are actually used in game. There's a Blender export plugin for it, and it will be available, and currently is available on GitHub, and there will be a link to it in the Discord. With that add-on added to Blender, you can go to the export menu and export a P3DI file. And again, only the visible meshes in your Blender file will actually be exported to this P3DI. You then take this P3DI file that you've exported and you compile it with a certain number of options. And with there are different things that you can do when you compile it that may perhaps improve your workflow. And we'll get to those. But you then compile this intermediary file into a file that's used in game. And obviously this requires the Blender add-on. So when you go to compile your model, you're going to use a tool called P3DI Tools, which is also available on GitHub and will be linked both at the end of this and at the last slide and in Discord. The idea is that you download this tool and you unzip it, and in the zip file there's a single executable, an exe file. And so you take your model. If you're not familiar with working with the command line, you'll take your model and you'll put it in the same directory where your executable is, and then open the command prompt. And you can open the command prompt easily in a folder by typing it into the address bar as seen in the second picture on the right. The correct setup for compiling the file that we just exported from Blender is shown on top. So there is a carbine.p3di file right next to the p3di tools executable. Once you've opened the command prompt, you will need to type in a command similar to the command given, which is p3di tools.exe compile -m which tells the compiler that you want to compile a model specifically. You also have other options such as compiling a rigging file, which we'll get to when we talk about ships and ship customization and ship models. There are other options like snapping UVs to pixels, which can help if your Blender workflow was perhaps sloppier than you'd like, and it just makes sure that there are no visible seams. I'll link to the documentation of this tool, which explains all of the options in much greater detail. So you type in this command in the command prompt, and you hit enter. And if you're greeted with warnings, that's fine. The warnings aren't bad for your file and don't affect it in a meaningful way. But if you'd like to understand why that it's giving you a warning, there's more documentation again for this tool. It amounts to the materials that the blend file exports not being named correctly, and it's just telling you to perhaps check what you're naming them. So like, where do all these assets go? We've made all of these things. So we've made a model, we've made a texture, but how do we put it into a resource pack? Well, now's the time. And I really recommend that you download the example resource pack and example data pack and edit those instead of creating one from scratch. There are certain files that Minecraft requires you to have for it to quote unquote be a valid data pack or a valid texture pack, and it's not something that I'm going to cover here. It's something that's not unique to anything that we've come up with, and you can find all sorts of tutorials around those. But if you were to download the example resource pack and example data pack, it has both of those already defined, and you don't need to mess with them. The data pack is linked in Discord and will be available as a link on the last slide as well. Yeah, so they'll be in Discord. But if you want to start from scratch, you'll need to start with a folder. And this is, again, not going to cover the files that Minecraft requires. So this is just kind of an example of where all of the files that you made need to go. So you start with a base resource pack folder. And inside of that folder, you're going to want to put the P3D model that you just created. So I've renamed mine to Westar Carbine. This is the output of the tool that we ran in the command prompt. And this goes in the Assets PSWG Models Item Blaster folder. Similarly, the texture for this weapon goes in the Assets PSWG Textures Model Blaster folder. And the texture is named the same thing that the blaster is named. So Westar Carbine.p3d, Westar Carbine.png. If you have a sound file for your blaster, which is optional, you would put it in Assets, PSWG, Sounds, Blaster, Fire. If you do not have a sound file, that's fine. We'll cover that when we get to the actual data pack portion. If you want your files, or rather, if you want your blasters to have a translation into the language that your players are going to be using in their client, you're going to need a language file. So we're going to need to create a JSON file. Anywhere is fine. You could open Notepad and do it. And the valid language entry for the blaster that we're working with in this example is given in that text block below. It is, again, already defined in the example resource pack. So if you'd rather just edit that, that's fine. It mentions a number of attachments that we have not yet talked about, but they were visible in the model, so maybe you see where we're going with this. You would save that as a JSON file, and as a note, if you're saving it from Notepad, you're going to have to change the save as type from .text to all files, so it does not save it as enus.json.text. And the destination directory for that is going to be assets pswg lang. And as an extra note on sounds, if you did define your own sound, you must also add a special file at the root of the assets pswg directory in your resource pack called sounds.json. And just as the same process that you edited the language file JSON, you're going to need to put a sound JSON, and that tells the game that it needs to load that sound when the game is launched. So the sound key is going to be blaster.fire and then the name of your blaster in this example, which is Westar Carbine, and then the directory where it can find that sound, which is relative to the root of the sounds folder. So from the sounds folder, it would be blaster, fire, Westar Carbine. It does not need the file extension. So now it's time to actually get into the Datapack. Like we mentioned at the very beginning, there's only one file in the Datapack, and that is the blaster descriptor. And there is one of these per blaster. So you can define as many as you want. All of them are going to have the same structure, and the game will automatically load each JSON file in the data PSWG items blasters folder as a blaster that gets sent to the client. So inside a new Datapack folder or editing the example folder, you would go to this subdirectory and your JSON files would be here. And so now we're going to get into just the contents of this JSON file, which is big and scary, and there's a lot of content in it, but I'll kind of touch on each option, and if you want to know even more in like way more detail than I could ever hope to cover here, if you'd like to know way more details about each option and what they do and how they work, the official documentation for this format will again be linked at the end and will also be linked in Discord. So starting from the top, there are a couple gimmies. The version of the file is always one, or it's always one right now, because we're in development. As soon as development is done and we move on to 1.0, if we ever make changes to this file again, that number will increment, and hopefully they'll be backwards compatible, but I can't guarantee that. And so this just tells the game to don't bother loading versions that it doesn't support. The next one is the type, and it is basically just an archetype for what kind of gun you've defined. And you have a few valid options. There's pistol, rifle, sniper, heavy, slug, and ion, and you must choose one of them. And right now, I believe it's just used to determine the stance that the player uses when they're firing it. But there is more documentation on that, again, in the official document for it. The sound is the name of the sound that gets played when it fires. This is the same identifier that you used in the sounds.json file, or it may be one of the identifiers that the game defines, or rather that the mod defines, which is available again in the documentation. So for this example, it is PSWG : Westar Carbine. The next block of things are some basic weapon information. So the firing modes define in what ways that you can operate the weapon and in what order they appear to the player. So when you first get this particular weapon is going to be in automatic mode, since that's what's first. And then if you cycle the firing mode, you'll then reach semi-automatic and then stun, and then it'll wrap back to automatic. There are multiple available firing modes. There's semi-automatic, there's burst fire, automatic, stun, which is the blue circles, slug, which is what most slug throwers shoot, like the Tuscan Cycler, or ion, which is what ion weapons like the Jawa ionization blaster fire. The next one is the amount of damage that each bolt, when it hits the player, will deal, and that is in half hearts, which is in-game damage units. The range is the distance that each bolt will travel in blocks before just kind of dissipating. Weight isn't currently used, but do set it to something sensible because we might be using that field in the future. It does not have a unit. It's kind of just relative to other weapons. 0 would be no weight, and this weapon uses 6.7. I suppose that's sort of arbitrary. The next field is bolt color, and this is the color of the glow that the blaster bolt fires, that the blaster bolt renders with when it's fired. The Westar carbine fires yellow bolts. So if we look at our color wheel here, we've selected a fully saturated yellow hue with the hue at 60 degrees. So the number that you would use in the JSON file would be a fraction of your hue divided by 360. So this hue here, since it is 60 degrees, is 60 divided by 360, which is approximately 1.667 rounded. Moving on, we have a couple of different firing and bolt-related fields. The first one is the magazine size, which is how many shots the blaster can shoot before it needs to reload. The automatic repeat time, which defines how quickly it can shoot in automatic mode. The burst repeat time, which is the same thing but is the time between burst shots. Burst size, which is the number of shots fired during a burst. And then we have recoil, which defines the maximum amount of degrees per shot that each blaster or that each shot will apply to the player. And spread is the maximum amount of degrees in any direction that the bolt may deviate from perfectly straight. And then we move on to heat, which is its own block. Heat has a number of fields. The most important one, I believe, is capacity. And if you've ever seen the little white bar underneath your blasters, that is defined by the heat capacity of your blaster in heat units, which is an arbitrary unit. So from 0 to capacity, it is rendered on when you're filling up with heat. And we'll move on to other views in a moment. But this blaster has 1,008 heat units, and everything else is relative to that. So the amount of heat that it accumulates per round is applied to the blaster every time a shot is fired. So that is the per round field. The passive cooldown delay defines the amount of time in ticks after the most recent shot was fired before it'll actually start cooling down on its own without you manually venting. The overheat penalty is when you overheat a blaster, how much extra heat is added on top of capacity. Apparently I wrote that as passive cooldown delay. So the last two fields in the description are actually wrong, so I'll just manually go over them. And of course, all of this is explained in even greater detail in the documentation. So the overheat penalty is the amount of extra heat that gets added to the accumulated heat when the blaster overheats. So when you overheat, it effectively prevents the blaster from starting to visually cool down until you've bled off the overheat penalty amount of heat. And the blaster will bleed heat at the rate defined by overheat drain speed. Overcharge bonus, if you select or are able to recharge your blaster during the secondary cooldown period, which we'll talk about on the next slide, the blaster will be granted, in this instance, 80 free ticks of not needing to accumulate heat. So you can fire without accumulating heat for 80 free ticks. And that's just like how Battlefront does it. And so this is the real meat and potatoes of cooling, or of bypassing and venting and all of that. So you define 4 different fields here, and 2 of them are each related. You've got the primary bypass time and tolerance, and that's the blue rectangle on your cooldown bar. And the time defines the center of the bar, or rather of the rectangle, and the tolerance defines the radius of that rectangle. And we've got a primary one and a secondary one. The primary one, if you click during that period, your blaster will vent all heat but you'll get no overcharge bonus, so your blaster will immediately start accumulating heat with the next shot. But if you get it during the generally smaller and harder to hit secondary bypass period, then you will have you'll be granted usually some amount of free ticks of not accumulating heat. And here's probably the trickiest part: attachments. And I'm going to kind of gloss over a lot of the complexities of it here, because there's just an extraordinary amount of detail that you could go into to try to figure out how attachments interact with each other, and that's all documented again in the documentation. But the gist of this example one is 3 different attachments that you can have on in any order and at any time. And there is no requirement to have a certain kind of attachment on, and none of them are mutually exclusive to each other. So in your attachment map, the key of each sub-attachment field is going to be an increasing power of 2. And the reason for that, as explained in the docs again, is it's a bit field, which it totally explains, but I'm going to kind of gloss over here because it's not really relevant. And so you've got increasing power of 2 keys, and the values for each of these objects has 4 fields. The mutex, which we're glossing over, the ID, which is used to generate a language key when the text for that attachment is rendered. So the ID for the first one is scope, and as you see at the bottom, there's a language key called blaster.pswg.westaircarbine.attachment.scope, and the .scope is coming straight from this file. It uses icon number 2, which is, if you look in the icon table, the scope icon, and the visual component, so the mesh that gets rendered when this attachment is applied, is the scope mesh, and you can see that that directly correlates to attachments in the Blender file. If your mesh has a name that is not associated with an attachment, it will always render. However, if your mesh has a name associated with an attachment, it will only render if that attachment is applied, which sounds complicated, but it's pretty straightforward to actually apply that. So it means that if you have an attachment mesh, or you have any mesh in your model, if you don't relate it to an attachment in this file, it'll just always render. So you never have to worry about it. We define two more attachments, and the mutex that we've glossed over is always the same in this example as the attachment key. So glossing over that, we've got a stock and an underbarrel. The stock uses icon 3, which is the stock icon, and the underbarrel uses the barrel icon, which is icon 1. 2 other things that I skipped are the attachment default and attachment minimum, and they are related to the mutex that we skipped over. It's sort of a complicated system that is only relevant for blasters with like much deeper attachment compatibility, but for a blaster that just has basic attachments like this one, we don't need to cover it. And again, there's much more information in the documentation, and there will be a link to that, I believe, in just a moment, and in the Discord. So where do these go? So you've got your resource pack and you've got your data pack. If you want to apply a resource pack, this is the exact same as probably all of you have done. They're global for the client. And if you go to Options, Resource Packs, and Open Pack folder, you take your zip file and you place it in the folder that is opened when you click that button. For Datapacks, it's somewhat similar, except, again, because they're local to the world itself, and they're unique so that they're not globally applied to the entire client. You apply them generally when you create a world or create a server. So again, they're specific to the world. And when you create a world, you're prompted to add one. So if you click New World, and then Data Packs, and then Open Pack folder, similarly to Resource Packs, the folder that opens is the place that you'd want to put your data pack. And here are some links. All of these will be in Discord. And in video form, these will all also be in the description as well. And so we've got the link to the tools that you're going to need to compile your P3DI model into a P3D model. We've got the complete documentation for how the Blaster JSON file should be formatted. And we've got a full example resource pack and data pack as zip files in the folder linked here. So I think we should go ahead and test out both of the example data pack and the example resource pack so that we can get an idea of what we've just accomplished. So if I go to options, I'll apply a resource pack. I don't currently have it in here, so I'll open pack folder. Here are my resource packs. And so if I go grab the example resource pack, I can just drop it right into this folder. Here's the example resource pack. And if I go back here, I can apply it. The game will reload. And now it's time to make a new world. So I'll create a brand new world, even though I already had some. And if I go to Datapacks, and if I open the pack folder again, I can take the example Datapack zip, plop it right into this folder. If I come back, done. It'll validate it, and we're off. Should probably be creative. And so now when you get into the world, your new blasters will be available to you. And if anybody else joins your world, the blasters will be available to them as well. It is something to note that if you're hosting a server, that you're going to need to make the resource pack a forced server resource pack. And there are tons of tutorials online to do that. But that is something to keep in mind, that, again, if you're running a server, all of the players will need to have your resource pack applied on their client. And Minecraft provides a way for you to do that through the server resource pack system, which I will find a tutorial for and link to everyone. So if we go to blasters, we now see that we have our CCT Westar Carbine, which is the blaster that we have just added through all of the all of the customization we've been doing today. So if we get a blaster workbench, we'll see that our Westar Carbine has, as we expect, the underbarrel, the scope, and the stock. And we can rotate it around and look at it however we want. There aren't any more attachments, so I'll just take all of them. And so now it's a little small, but we can hold it in our hand, we can look at it, and most importantly, we can fire it, and it fires little yellow bolts. It makes a particularly odd sound, but this does confirm that our blaster does work exactly as we have intended it. And so now I get some overcharge. And that's that. We've created our very own blaster, and anybody who joins your world will be able to play with your blasters as well. And I think that just about covers it. So I'm going to link everybody in Discord to the all of the links that are at the end of this slide. I'm going to be putting it in the developer news channel. So I'll actually show you the process of me doing this so you can see exactly where I'm putting it. So in developer news, we'll have P3DI tools, all one word. We'll have the blaster documentation, which is already linked. It's linked right here, the message immediately previous to it. And we have all of the example data packs and resource packs. And I'll publish both of these. And now everyone should have the resources required to start making their own data packs. And again, if you have any questions regarding the specifics of the example packs, the specifics of modifying the actual file that defines the blaster descriptor, if you have any questions, please reach out on Discord. We'd be happy to walk you through everything that you'd need to know. The system is going to very slightly change coming up soon, because again, blaster attachments don't have any functionality, so we won't be changing anything that you learned here today except for adding more options for attachments in terms of functionality. So everything that you learned is still relevant. There will just be a few more things that if you'd like your attachments to do something, that you'll have to learn in addition. But as soon as those changes are ready, we'll make a post in developer news. So make sure to subscribe to that uh, announcement channel, or just keep tabs on it, and you'll see when we make those changes. Um, but yeah, I think that just about covers it. Thank you everybody for coming over, and thank everyone for uh, your continued support throughout this very weird development cycle.
Yeah,
Um,
and thanks for tuning in. It was long and very technical, but very informational as well.
yeah,
So hopefully we see some community blasters coming soon from
yeah,
you guys.
absolutely. We'd be more than happy to promote or have a channel for you guys as community add-ons. We love seeing the things the community have made so far, and we really look forward to the stuff that you'll be able to make going forward. We have a lot of plans for customization in the future, whether it be in-game customization for your player or server and world customization in the form of Datapacks. There's a lot more coming your way eventually before 1.0, so definitely stay tuned for that. If you make something, please share it. We love to see it, and we'd love to talk to you about it. And we may even feature them in the form of screenshots or something like that in a cool place going forward. So we'll see about that. But yeah, thanks everyone for tuning in. Hopefully this wasn't overwhelming, and if it was, please let me know. Or if you have any questions, don't be afraid to reach out. But I think that's all for today. So thanks everyone for tuning in.